Hi, I'm Nick Raboy from MongoDB. In this tutorial, we're going to see how to use LINQ to query MongoDB in a .NET Core application. So if you've been keeping up, I do have other tutorials that I've published both on YouTube as well as the MongoDB developer blog around .NET Core and MongoDB. But this time we are going further in the series and we are actually going to be using LINQ in this example. Now, what you will need prior to starting this tutorial, you will need .NET Core installed and configured. You will also need a MongoDB Atlas cluster deployed and configured. For the sake of this tutorial, I am going to be using the free tier. Go ahead and use whatever makes the most sense to you. You will also need the sample databases and sample collections available to you. We will be using the sample mflix database in particular. If you're unfamiliar on how to obtain that, after you've logged into MongoDB Atlas, you can click on the ellipsis menu, and then you can say load sample dataset, and that's all there is to it. Now, if you haven't seen those other tutorials, they are not a requirement to be successful with this particular tutorial, although you will find them beneficial in the long run. Now, let's go ahead and get right into it. So what I have is a .NET Core project. This is a console application. We're going to keep things simple for this particular example. This console application does already have the MongoDB .NET Core driver installed. If you need help installing that, all you have to say is .NET add package MongoDB.driver. And executing that command from the command line will install the latest version of the MongoDB driver for .NET Core. So within your .NET Core project, let's go ahead and open up the program.cs file. What we're going to do is we're going to establish our connection to MongoDB Atlas and configure our LINQ provider. So let's go ahead and add the following. Let's go ahead and say Mongo client settings, and we're going to say settings equals Mongo client settings dot from connection string. And we're going to use a variable that's found within our environment variable. So if you haven't already set that up, please go ahead and do so. While you could hard code this connection string directly in the .NET Core application, for security purposes, it's probably a better idea to use a configuration file or an environment variable like we're going to do in this tutorial. So let's go ahead and say environment dot get environment variable. And I've called my environment variable Atlas URI. Now, if you're not sure what that Atlas URI string looks like, let's go ahead and go back into our MongoDB Atlas dashboard. Let's click on connect and then say connect to your application, choose C#.NET, and then go ahead and copy that connection string. You will want to replace the username and password with the username and password that you've configured when you deployed this particular cluster. Let's go back into our Visual Studio Code. And let's continue setting up our boilerplate for this particular project. With the settings, let's go ahead and say that we want to use version 3 of the LINQ provider. Now, by default, it uses version 2, and while that works for a lot of different queries as far as MongoDB and LINQ, you're going to get a much better experience using version 3, which is not the default for our project. So to set version 3, let's go ahead and say the following. Settings.LINQProvider equals LINQProvider.v3. Finally, let's go ahead and establish a connection. So we're going to say Mongo client equals new Mongo client settings. Now, if you've been keeping up with those other tutorials like I previously mentioned, the way that we connected was slightly different between this one and the last few. That's because we actually did want to set the LINQ provider version in this particular tutorial. So our boilerplate should be good to go. Now let's go back into MongoDB Atlas and let's go ahead and say Browse Collections. And then let's go ahead and click on our sample mflix database. And the collection that we're going to be using for this particular example is the movies collection. Now, to get an idea of what those documents look like, it's just information about a particular movie. So it has the plot, it has the list of cast members, the title, the runtime, etc. You may want to become familiar with this particular collection, even though we're only going to be using a subset of the fields for each of these documents. All right, let's jump back into our code. So we're going to go back into, in my case, Visual Studio Code. And because we plan to work with a particular collection and because we plan to use LINQ, it's a good idea to establish a class where each field of that class maps to a BSON field in our document. So to do that, let's go ahead and create a new file within our project. I'm going to call this movie.cs. And within movie.cs, what we want to do is we want to do the following. We want to say using MongoDB. We want to say that we're using BSON, and we're going to say using MongoDB. And we're also going to say that we want to be using MongoDB.bson.serialization.attributes. And this will allow us to do mappings on all of our class fields. So we're going to say public class movie, and we're going to find those fields that we want to work with. And like I mentioned, we're only going to be using a subset of those fields, and I'm going to show you a trick to make that possible in just a moment. So let's go ahead and define public string ID. So this is going to be our document ID. We're going to say get set. Next up, what we want to do is we want to say that we have a title. So we're going to say public string title. And we're going to say get set. And we're also going to say that this one can be null. We're going to say public int year. We're going to say get and set. And we're going to do the same thing for a few more fields. So we have a few of our fields defined. If we left it as is, we would be expecting that our MongoDB document, so the documents within our collection, the fields would have a uppercase T or an uppercase Y, etc. But if we look back at our document in reality, all of this is lowercase. So we do need to define a proper mapping to these BSON documents. So let's go back into Visual Studio Code, and let's go ahead and define those mappings, starting with the actual ID, which in our case is not actually going to be a string, but instead a BSON ID, so an object ID. To do that, our first mapping, we're going to declare this as our BSON ID. We're going to say that this is a BSON representation, and it's a representation of BSON type.objectID. So we can work with it locally as a string, but we know that when it gets mapped into our MongoDB document, it's actually going to be an object ID. Let's go ahead and do our title. So what we're going to say is we're going to say BSON element. We're going to say this is going to be called title with a lowercase t, and we're going to do something similar for each one of these other fields. Now, in addition to mapping each of these fields as they should exist inside of our database, we do want to make an adjustment to two of these fields. So for example, the plot and the cast, which are nullable values. If these happen to be null, it might be a good idea, and this isn't absolutely necessary, but it might be a good idea to say ignore it if it is null. So what we can say is BSON ignore if null. And we're going to do the same thing for both of these nullable fields. And we could easily do that on the title too, but every movie should have a title. All right, there's one more thing that we want to do. So we know that if we look back at our document within MongoDB, we have quite a few extra fields that we could potentially be using. Now, rather than including each of those fields within our class, we're not going to be actually using those fields in this particular example. So the top of our class, what we're going to say is we're going to say BSON ignore extra elements. And it's just going to ignore all of the fields that we did not include. We won't be writing any data. We're only going to be reading with our LINQ queries. So this is perfectly suitable for this particular example. All right, so we do have our class. We can actually jump back into the program.cs file, and we can get down to business on making everything possible. Now, what we're going to do is we're going to work our way up. So we're going to start with very simplistic queries, and then we're going to work our way up into a more complex data aggregation. So let's go ahead and start by saying the following. So what I'm going to say is Mongo collection, and this is going to be of type movie. I'm going to say movies collection equals client.getDatabase, and this is going to be sample mflix. Then I'm going to say get collection, and this is going to be of type movie, and this is going to be the movies collection. So this is the collection that we're going to use. And what I can do is I can say Mongo queryable, and this is going to be of type movie as our response, and we're going to say results. And this is where we can actually provide our LINQ query. And this is going to be pretty much the same kind of LINQ query that you would do even without MongoDB. This is a feature of C# and .NET and .NET Core, but we're putting a MongoDB spin on things so that way we can actually interact with our MongoDB data. So let's start writing that query. We're going to say that the results, what we're going to say is we're going to say from, we're going to say movie, and we're going to say in the movies collection that we had just defined. And we're going to say as queryable. We're going to say that we want all movies, and this is just an example, all movies between the years 1980 and let's say 1990. So we're going to do a where clause. So we're going to say where, we're going to say movie.year because we're working with it with a capital Y because that's what we define in our class, and it'll map appropriately within our database. We're going to say where movie.year is greater than 1980 and movie.year is less than 1990. As far as what data we want actually returned from this, we're going to use a projection, and that projection is in the form of a select. So we're going to say select, and we're going to return the entire movie document or whatever we've mapped in our movie class. So all of those fields. I'm going to add a semicolon there. Now with that query in place, let's actually print out the results to the command line. So I'm going to say for each movie result in results. What I'm going to say is console.writeLine. And I'm going to print them out. So I'm going to use placeholder variables. And for those placeholder variables, the first one is going to be the result.title. And the second one is going to be the result.plot. So even though that we have other fields in our class, which I'm going to show you how to work with that in just a moment, we're only going to be working with the title and the plot. So let's go ahead and save it. And we're going to try to run it. So in our command line, we're going to say .NET run. And it did print out quite a few movies, but it printed out, for example, on the left of the colon, it printed out the movie title. And on the right, it printed out the plot. So exactly what we expected. And this was actually done using a LINQ query. So all movies between 1980 and 1990. Now, I did mention that we chose to return the entire document or whatever was defined in our movie.cs file if we only wanted to provide certain fields to be returned rather than the entire document, because this particular collection, the documents, they have quite a few fields. And if that information is not important to you, it probably makes sense to limit what's returned. So that way you have faster network latency between the client that requested this information and the database. So let's say that we only want to use the title and the plot. So instead I can say select new, and then I can define an object. So let's go ahead and say that we want to return movie.title as well as movie.plot. And you'll notice that it is yelling at me a little bit because our data type is different. We're not returning a movie, we're returning just a title and a plot. So the easiest way around that would just to change iMongo queryable to var. And then we can make an adjustment inside of line 20 for this loop. Instead of movie, use var. And you could define the actual type if you really wanted to, but for this particular example, the var works out fine for us. So let's go to run it and make sure that we still get results. It looks like we still got results, and without actually looking at them, I'm assuming that they are the same. They should be the same. Nothing really changed. All that we defined differently was our actual projection, because now we're projecting only the title and the plot. All right, let's start making different adjustments to this particular query. So we saw how to use the AND operator and some basic less than and greater than. Let's say that we want to search between arrays. So for example, if we go to the movie class, we notice that we have a list of strings for cast members. So we can actually get information regarding which cast members appeared in which particular movie. But let's go ahead and say that we want to search for only movies that had Michael Keaton as an actor. So we would want to search within that array. And that can be done very easily with LINQ. So let's make an adjustment to the where condition, so the where clause. And this time around, what I'm going to do is I'm going to say movie.cast.contains, and I'm going to say it has to contain Michael Keaton. And I'm going to use the title and the plot once again. I'm going to run it in my terminal, and we're going to see what Michael Keaton results we actually get. So in this particular return, the results, they're different. And I think they're probably a lot fewer as well. I mean, Batman should be one of them, but there's a bunch of other movies that Michael Keaton appeared in as well. So we actually searched for data within that array. So those are very simplistic Mongo Query API queries. Let's go ahead and take things to the next level. Let's say that we want to do a more complex data aggregation. So this would be traditionally done using the MongoDB aggregation pipeline. We'd be working with multiple stages in a pipeline. And as seen in a previous example, as you start adding stages, things can get a little more messy when it comes to C#. And this is where LINQ particularly shines because you can make it very clean, very readable, very short. And we're going to see that right now. So let's go to make some adjustments to this particular query. We're still going to be querying from the movies collection, but this time around, let's say that we want to find out how much screen time a particular actor has had. So what we're going to say is we want to find all documents or all movies where this particular actor has acted in. We want to sum up the movies for just that particular actor, the runtime, and then we want to return that as a result. So traditionally what we would do is we would do a match operation, we would do an unwind to flatten that array, we would do a grouping, and we would use an aggregator for that grouping. We would be using a sum operator. It'd be a multi-stage pipeline. And this is what we're going to do with LINQ. So starting things off, what I'm going to say is I'm going to say where, and I'm going to say movie.cast.contains. I'm going to search for a particular actor once again. This time around, I'm going to say Ryan Reynolds, also known as Deadpool. He was in the Deadpool movies. What we're going to say is we're going to say from. So we found all documents that contain Ryan Reynolds in that array. Now what we want to do is we want to flatten that array. So we want to use an unwind. So that way now we're working with no more arrays. So what we can say is we can say from cast in movie.cast. So we're flattening that cast array into a cast variable. Next up, what we want to do is we want to say where cast equals Ryan Reynolds. I need to spell that correctly. So we trimmed down the amount of documents that were returned in that first where condition. We unwound those results, and now we're further limiting the result set by searching for only flattened documents that contain a cast of Ryan Reynolds. All right, so we're moving along. So we have just Ryan Reynolds documents, and what we can do now is we can say group, we can say movie by cast into whatever we want to call our group. In this case, I'm going to call it G. And let's define what we want to actually return. So we have a grouping of those documents. Had we had more actors, we could say that we want to group it by a particular actor, or in this case, it's already grouping that way. But we can say select, we can say new, so this is our projection. I'm actually going to name these variables in our projection. So I'm going to say cast equals, I'm going to say g.key, so the grouping key, which in this case, once again, is the actor. After we define the cast here, or what we're grouping on, I'm going to say that we want to calculate the sum. And we're going to say sum, which is the name of our variable. It doesn't have to be called sum, but we're going to say equals g.sum. And we're going to say x, and we're going to say x.runtime. So it's going to sum up all of the runtimes for this particular grouping. So all of the Ryan Reynolds documents. I'm going to add a semicolon there. Now, as far as our results go, as far as printing them out goes, we no longer have a title to work with or a plot. We now have an actor and a runtime sum. So let's change it up a bit. So we're going to say cast, and we're going to say sum because that's what we called it. And I'm going to save it, and I'm going to run it and see what we get. So Ryan Reynolds, according to our results, had 1,941 minutes of screen time or runtime. So not bad. We did an aggregation pipeline, and there's probably 100 other ways to do the same calculation within MongoDB. This is just one of them, but it did demonstrate that we have a multiple stage aggregation pipeline. So as far as the stages are concerned, we have one stage, which is our first match, a second stage, which is our unwind, third stage, which is another match, fourth stage, which is our grouping, and our fifth stage of the pipeline is our projection. So not bad. So this was just a quick example on how to use LINQ in your .NET Core applications to work with MongoDB. So it's not the only way to do business, but it is kind of the .NET way of doing things. It's definitely easy when your aggregation pipelines can get kind of messy. So it's definitely an approach that you might consider using. But once again, I want to reiterate, this is not the only way to do business. If you enjoyed this tutorial, please take a moment to hit that like button on the video and then subscribe to the YouTube channel. It really does mean a lot to me when you do that to my videos. Until next time, keep an eye out for other .NET and cool MongoDB content.